All right, AQR students, we're looking at student activity sheet number 6, rates of change in exponential models. So we're starting with this equation y equals 2 to the x power. Consider the exponential function y equals 2 to the x. Fill in the table of values for the function and find the rate of change between consecutive values in the function delta y. What pattern do you see for delta y change? All right, so if I put in 0 for x, 2 to the 0 power, anything to the 0 power is 1. Put in 1 for x, 2 to the first is 2. Put in 2 for x, 2 squared is 4. Put in 3, 2 to the third is 8. 2 to the fourth is 16. 2 to the fifth is 32. Delta y is the differences between any line and the line previous. So 2 minus 1 is what we're doing here, equals 1. And then 4 minus 2, I'm just subtracting 4 minus 2 equals 2. 8 minus 4 is 4. 16 minus 8 is 8. 32 minus 16 is 16. And what do we see with delta y? We see that delta y is doubling in value each time. Like y, but lagging. Okay? It's like one line behind, right? 1 goes 1 here, 2 and 2, 4 and 4, 8 and 8, 16, 16. All right, number 2. Student activity sheet 3, we talked about MRSA. We had some scientists, they're growing MRSA in an agar dish. The initial area occupied by the bacteria is 2 square millimeters. They increase by 20% each week. Table below gives the area of the bacteria over several weeks. Use the table to describe the rate of growth of the area of the bacteria. So if I do delta A here, how much it's growing by, I get 2.4 minus 2, which is 0.4. And then I have 2.88 minus 2.4, which is what, 0.48. And then 3.456 minus 2.45, minus 2.88, that's 0.576. 4.147 minus 3.456, that is 0.691. And 4.977 minus 4.147, that is 0.830. All right, so I'm not seeing, just looking at these numbers, I can tell it's increasing. It does not increase by a constant amount every time. This increased by 8/100ths, and then it increased by, 0.1 something after that, and 0.1 something after that, and 0.1 something after that. So it's increasing, but it's not a constant increase. Okay? So I'm going to break out the calculator here. If I divide these, if I do 0.48 divided by 0.4, you'll see I get that 1.2. 0.576 divided by 0.48, I get 1.2. So my common ratio of my deltas here, I would start, I'm not going to have anything for the first 2 lines, but 0.48 divided by 0.4 equals 1.2. 0.576 divided by 0.48 equals 1.2. 0.691 divided by 0.57, this is probably rounded, it's probably not going to be exact, but we'll see. 0.691 divided by 0.576, yeah, you can see it, I got 1.1, well, it rounds to 1.200. And then the last one here, 0.830 divided by 0.691, 1.201. All right, but roughly 1.2, which remember is exactly what we multiply each of these by to get the next number. All right? So that's my common ratio. So number 3 now. Suppose a quantity increases at a rate proportional to the quantity. And the constant of proportionality is 0.2. The initial quantity is 2. Write a difference equation that describes the statement above and find several values of this quantity. Well, I'm going to do it in different order. We're going to go on and fill in the table, and then we'll write the difference equation in just a minute. So, the constant proportionality is 0.2. I'm starting with 2, so my delta y is 0.2 times 2, which is 0.4, and so I'm going to have 2 plus 0.4 to get 2.4. And then I would have 0.2 times 2.4, which is 0.48, and I'd have 2.4 plus 0.48 equals 2.88. These numbers probably look familiar to you. And then I would have 0.2 times 2.88, and that's 0.576. So 2.88 plus 0.576 is 3.456. And last one here, 0.2 times 3.456 is 0.6912. And if I add that on, I'm going to get 4.1472. Okay? So what are we doing every time? Our delta y is equal to 0.2 times y, right? I do 0.2 times y to get delta y, and then I take that delta y and I add it on to y, all right? And remember, x sub 0 here is equal to 2. We're starting with 2. That's my initial amount. I really should say y sub 0 maybe. Y sub 0 equals 2. Okay? Y sub 0 is equal to 2. All right. So now we're going to use the spreadsheet. So, on your computer, I want you to go to Google Sheets. I need to type in my password real quick. Hopefully this will work out okay. So go to Google Sheets. Okay? And what we're going to do is we're going to type stuff in here, and we're going to let the computer do the work for us here. It says, number 4 says use spreadsheet software to generate about 75 values of the table you started in question 3. Spreadsheet allows you to use a recursive rule to generate the data. All right, so my first column I'm going to put in is my time. I'll put in T there. My next column is my area, so I'm going to put in a capital A here. And I'm just going to, just to make it look a little nicer, I'm going to put those in the middle. There we go. All right, so I'm going to put in 0. I'm going to start week 0. I hit the tab. I'm starting with 2 square millimeters. Okay. Each time I'm going to put an equal. I'm going to put a formula here. I'm going to say equals, and now I'm going to click on my top on this. Click on A2 equals A2, and each time I want to add 1. So I'm going to hit Shift plus 1. So equals A2 plus 1, and I get a 1 in there. Okay. For this formula, I want equals. Click on B2 plus, Shift plus B2 times, and for the times we're going to use the asterisks, Shift 8 times 0.2. And that gives me 2.4. Now I'm going to highlight those two scales, excuse me, not scales, cells that have the formulas, and I'm simply going to drag it down. I'm going to grab the bottom right-hand corner here, and I'm going to drag them down to copy those formulas down. All right, and I'm going to have to go down to about, number 77 or so. Will that give me 75? Yeah, there we go. That gets me 75. Okay? So let's kind of go back to the top here. All right. We can see, you know, after 8 weeks, we had, this was each week. After 8 weeks, I had 8.5 square millimeters. After 9 weeks, I had a little over 10. After 10 weeks, I had a little over 12. I passed up 20 at 13 weeks. I passed up 30 at 15 weeks. I passed up 40 at 17 weeks. And then 18th week, I passed up 50. Okay, so by this time, it's growing pretty quick. It's growing pretty quick here. All right. So this is just growing 20% each week unbridled, right? Okay? And you can see it grows and grows and grows, so that by the time we get down here to the bottom, I've got, what is that? Over 1,700,000 square millimeters, which that's huge. I mean, that's pretty big. If I took this number and took the square root, 1,736,294. That's going to be 1317. So we're talking about a meter on each side, you know, more than a meter. 1.3 meters on each side, and meters, you know, about a yard. So you're talking about 4 feet by 4 feet square of bacteria now, where we started with just a little 2 millimeters by 2 millimeters. Actually, not even that much. It was 2 square millimeters total, so 1.4 millimeters by 1.4 millimeters. Now we have about 4 feet by 4 feet. We've got lots of bacteria, crawling with bacteria. Okay? All right, so number 5. Last thing we're going to do here with the spreadsheet. The agar dish that the MRSA bacteria growing in has an area of 1,000 square millimeters. So we're way beyond that after 75 weeks, way beyond. The growth of the bacteria is limited in the lab by the size of the agar dish. The growth of the bacteria can still be modeled by a proportional difference equation, but now the rate of increase of the bacteria's area is directly proportional to the bacteria's area and the difference between the agar dish's area and the fungus's area. This constant of proportionality is the ratio of the original constant of proportionality, 0.2, and the maximum area the bacteria can reach, 1,000 square centimeters. So you can see this ratio right here. The difference equation can be written as this: 0.2 over 1,000 times A times 1,000 minus A. So let delta T be equal to 1 to simplify your work, and then use the difference equation to find the new values of A. Use a spreadsheet to calculate about 75 values. All right? So let's see if this works. We're going to let delta T be equal to 1. We're looking for the change in A here. All right? So if we start with 2. So once again, I'm going to start with 2. Let me go back up to the top here. And this time, now, I'm going to actually change the title on my A here. I'm going to call this A unrestricted. I'm typing at an angle here. That's a little bit tough. All right, now I'm going to call this one A restricted, because the bacteria is restricted by the size of the agar dish. All right, I'm still going to have a 2 here, starting with 2 square millimeters. But my formula now, I'm going to say equals, I'm going to say C2, I'm going to click on C2, plus, now here's where I'm going to use my formula. I'm going to say 0.2 divided by, there we go. Nope, that's not right, not shift, just that. 0.2 divided by 1,000 times Shift A times C2 again times parentheses 1,000 minus C2. I'm going to close my parentheses, and I'm going to press enter. And notice that I get not quite 2.4. It doesn't grow quite as much with this restriction. Okay? So, I'm going to show you now, I'm going to pull it down a little bit here. In fact, I'll pull it down to 10, but I want you to pull it all the way down to 75 and just see what happens. All right, so you can see after 10 weeks, I had 12.3834. Can you see that okay? Before I had 10 weeks, 12.3834. And now, after 10 weeks, I have 10.277. So not a huge difference, just 1/10 of a millimeter, square millimeter there. Okay? Not a big difference. I want you to pull it all the way down to 75 and see what happens there. All right? And then your last question, and so I'm going to ask you in the assessment, I'm going to ask you for what 75th week, what's your A restricted? And then number 6 says compare the data generated in the two, record your observations, and see what you think about that. Okay? And we'll stop there. We'll finish this up tomorrow. Bye-bye.